Alright guys, back at you with another quick video here. This one is actually pretty short and simple. This one is out of the lab book. It is EIGRP Stub routing. With this one, we have a pretty simple topology. So what we got going on here is routers 1 and 2 are participating in EIGRP. We're in 100 here. So everything that is connected on router 2 in regards to our 10330 network, our loopbacks, and our serial 10 connection, which is a 10220 network, and everything on router 1, so the 10110, and again the 10220 network. In regards to routers 2 and 3, we're actually going to set up a static route going from router 2 pointing toward router 3 to get to the 10150 network, and for the R3 router to get out, we're going to simply set up a default route pointing to router 2. To save time and hassle, as always, I've already pre-configured the interfaces and all the loopbacks. I have not configured EIGRP yet. That's where we're going to start this off. So let's go ahead and jump into it here. Should be pretty quick here. So what we're going to do is we'll jump in router 1, and we're going to do EIGRP 100. And we're going to simply add the 10000 network. Alright. And this isn't as clean. If you're wanting the topology table to be a little bit smaller, if you want to be a little more concise, if you want to do the 10110 separately and do the 10220 network separately, whatever. Alright. So router 2, we have to add our network 10000. That will get us a neighbor relationship here. Alright, so routers 1 and 2 are now talking. So now what we're going to do is we're going to add also the, I'm going to type network. I'm actually going to say 0.0. And we're just going to do the 192.168/16. That way we get everything in the loopback range. So now we've got that. So now we can take a look at our table here, and we should be able to see everything that we need to get to in regards to routers 1 and 2. Alright, so we can see the 10330 network, which is hanging off for F00. We have loopback addresses. We can see all of them here. So there we go. We'll go to router 2. And you can see we had 10110, and that should really be it because everything else is local. So that is up and running. Verify we can even do a ping 10111. We're good. We go back the other way, ping 10331, and we're good. So we have a full neighbor relationship between routers 1 and 2. So now our next step is we can actually simplify our routing table a little bit here. We can do a summary address for all of these. Instead of seeing on here we have 192.168.1.0/30, 192.168.2.0/33, and 4/30s. We can simplify that down a little bit. So we can do a summary address off of the interface that's pointing to router 1. So we're going to do int s10 and do a summary address EIGRP 100, and we simply set up our network here. So 0.0, and if you do a little subnetting here, that would be 255.255.2480. And we'll get a neighbor relationship is going to do a soft reset here. So now if we look at our routing table, now we've gone from 1, 2, 3, 4, 5, 6 lines down to 3. And believe me, when you start getting into a bigger enterprise network that is running EIGRP, that's kind of nice. It's a lot less CPU memory usage on a router if you can simplify that routing table a little bit. So we have that set up. So our routing table is a little bit smaller. So now what we need to do is, as I was saying, we need to get our static route and a default route so we can kind of get everything talking here. So in router 2, we're going to go to our interface S11. I gotta tell you about what am I doing here. We need to do an IP route, and we need to specify our route that we're trying to get to, which is 10150 network. So 10150, 255.255.255.0, and we're going to specify the next hop from router 2, which would be 10.44.2. Okay. So now we have a route to get to our 10150 network. And next on our router 3, we need to do our default route pointing from router 3 over to router 2 so we can get out to the rest of the place on the network. So IP route, and this is our quad zeros. The prefix, so all zeros again, specify everything. And our next hop is 10.4.4.1. There we go. So now, if we look up at router 2, we have our static route that are separated here. We're listing it with an S for static. 10.150 via 10.4.4.2, which is router 3. So we're good there. Let's do a ping 10.151. We have a response from router 3. And if we do a show IP route on this way, we should have our static default pointing to 10.4.4.1, which is router 2. So if we do a ping of, let's go across here. Let's go to 10.111, which is router 1. We get a response. However, if we go over to router 1 and we try to ping back over, we're not going to get a response. Now, why is it that router 1 is unable to ping router 3, but router 3 can ping router 1? Well, the issue comes in here is that router 3 has a static default route pointing to router 2, says, hey, I'm trying to get to 10.111. And router 2 knows how to get there. And so it relays the information down to router 1 and then sends it back over to router 3. However, router 1 still doesn't know anything about router 3 because the only route that is out there that points to the 10.1.5 network is router 2, and it has a static route pointed to there. However, this static route has not been sent to router 1. And we can verify this. We do a show IP route. We don't have anything that states 10.150. So now here's where the fun part comes in. So we need to set up EIGRP stub routing, or we could redistribute the static into EIGRP that way. But what we'll do is router EIGRP 100, RP, not PR, 100. And we're going to do a EIGRP stub. Now, with that though, there are different versions of EIGRP stub routing. I believe there's actually 5 of them. You have EIGRP connected, EIGRP stub static, EIGRP stub summary, and you have redistributed keyword. Now each one's going to do something a little bit different on it. And we'll go through that here. So right now we just have a regular plain Jane EIGRP stub set up here. If we look back at our show IP route, we still don't have anything pointing to the 10.1.5 network. Now, if we do something along the lines of getting the static from router 2 to router 1, we would need to do a EIGRP stub static. And here's our other commands we can do here. We have connected, redistributed, summary. So let's just do EIGRP stub static. And we'll get a resync. There it is. So now, if we take a look at our route, it's not there yet. There's a command we got to add. With EIGRP stub static, we also have to do a redistribute command. Router EIGRP 100 redistribute static. So if you want to send a static out, you have to do two commands. You have EIGRP stub static, and you have to redistribute the static. So you can't just do a stub static and expect the statics to go out. You have to redistribute it as well. So now let's take another look. There we go. Here is our external send in and 10.1.5.0. And you can see it's an external EIGRP route because it is redistributed. So we have a higher administrative distance here. But there we go. So now we should be able to ping 10.1.5.0. There we go. So now we can completely see all the way across the network. But now we're running into another problem. If you look here, we've lost our 192.168 networks that are the loopbacks of router 2. That is because we are only sending now the static routes through router 2 because we did a EIGRP stub static. So now we need to push this out a little bit further. We have redistribute stub static. Alright. As showed before, we have connected and summary. So if we do redistribute stub static connected, that should also send out anything that is connected to router 2. So we should see our 192.168 1.0 and 2.0, 3.0, 4.0. There we go. We have 1.0, 2.0, 3.0, 4.0. But as you see, this topology table is getting kind of big. So, as we did before though, we did a summary route for all of these loopbacks. We had that /21 that was originally showing up where we only had 3 lines in the IP route table. So, instead of doing connected, let's do static summary. Resync. And let's take another look. Boom. So we just dropped 1, 2, 3, 4 lines down to 1. So we basically eliminated 3 more lines of our routing table. So you got this monstrosity of a bunch of lines down to that. That's a lot cleaner. And we can still ping all the way across the network. We can get everything on the loopbacks on router 2 from router 1. We can get to router 3 from router 1. And we can get all the way across to everything else. So, router 3, let's go ahead and ping 10.1.1.1. Uh-oh. Now, what just happened here? There's stack pointing to 10.4.4.1. So it should be good. But we got something else going on here. We still got our route there. And that pings. 10441. Got a response there. Ping. Let's do 10222. We got a response. What did I miss? 10111. That should have pinged. Let's take a look back at router 2. Let's do a show IP route on here. 10111 via 10221. Yeah, that should be there. So now all of a sudden we do not have a response going back there. So maybe we need to change up our stub routing a little bit more. We may need to do a router EIGRP 100, EIGRP Stub connected, summary static. Figure out, we're still good. 1044. Now, so what we had here before is we only had the summary and static, but we weren't distributing the connected, which meant that we were not getting the 10444 or 10440. So we had no way to get back. So let's try this again. There we go. So you got to really watch how you set up these EIGRP stubs, because if you don't set it up exactly correct to get all the routes that you need, you could really mess yourself up here, as you can see. So it looked like we had everything, but there was just one route that wasn't getting put in there because I didn't have the stub connected, even though we had the summary, so we can get the 192.168 networks here and the router 1. So now we have full topology across. And that's one other thing we can look at here. Since we see that we have the full topology table and everything ping across and everything else, there's one other command in here that typically you would put on maybe if you had like a hub and spoke type topology with egrep running through, or it was maybe a full mesh. So say router 1 to router 3, we may have had a link here, and you don't necessarily want these two to communicate routes between each other because you want them all to go through router 2. Maybe this is a data center here, so you don't want to use this as like a transit router to get to here. For some reason, something maybe getting a little bit messed up, ISPs being goofy or something, and stuff starts routing through router 3 to get to router 2. Might not always want that, just so you kind of have an idea of your traffic flows, and you want everything really to go through your main router. So what you could apply would be something like EIGRP Stub receive only. Now what this does, this sends out none of its routing table that it will learn. So it doesn't participate in sending anything out, doesn't send out any of its routes. So if you look at router 1 now, we don't have any EIGRP routes coming through to it. We don't have our loopbacks from router 2 in there. We don't have the connected route to the 10440 between routers 2 and 3. We don't have the F00 networking off router 2. The 10.1.5 network, that was the static route pointing toward routers 3. So we don't have anything. So now this guy can't get out anywhere. And like I said, this would be more on the end if this was a computer going out to a data center or something, and you don't want the other routes to be advertised out. So it's kind of a good thing to have. It'll keep the topology table down, keeps the processes low on your routers, all that good stuff. Works good up to the point where maybe if your router is dual connected to multiple data centers, so if you have ISP1 is going to data center 1 and ISP2 is going to data center 2, and those two data centers have a like an OTV link in between them, and those two communicate, it is a little bit more difficult to do a stub routing in between them. It can be kind of messy. But if you're like a single leg connection or something, and you're going in between them, yeah, that'd be something okay to consider to keep the processes low on your remote routers. So hopefully this video has been helpful. Walk you through some of the EIGRP Stub routing options and how to summarize some of your routes out to free up resources on your router. And as always, like, comment, and subscribe. Let me know how I am doing, if there's anything else you would like to see, and I will keep on keeping on through this lab manual here. The next one I have is Lab 2.3. That is IPv6 for EIGRP. And as always, thank you for watching.